Welcome to part one of the A Squared I, E Squared C 2025 annual showcase. The showcase involves 4 presentations. The first presentation by Sasha Nikolic on project work, a starting point for generative AI integration. The second by Swapneel Thite and Giordana Orsini Florez on using AI to inform assessment redesign. The third by Zachery Quince on AI ethics. And finally, by Dr. Aneesha Bakharia on online modules to embed AI-assisted coding.
This first presentation introduces you to A squared I, A squared C, as well as project work. Okay, so engineers design and use tools all the time. We all know that. That's pretty obvious. These tools we create for a purpose to usually make things more efficient. A lot of these tools can have positive and negative impacts. For example, it could be argued that the efficiency of cutting down a tree can have negative impacts on the environment, allowing us to cut down trees faster. There are also diverse implications of using such technologies that the creator would probably never have imagined when designing it. So engineers are always connected with the idea of we need to do a risk assessment. So in 2023, when generative AI came onto the scene and it was told that we were informed that it would start passing all our assessment tasks, we formed a multidisciplinary, multi-institutional team, and we assessed our assessment tasks against the different technologies. And this has been a very highly successful paper. And from that, we were able to launch A squared I, E squared C. And back in 2023, we saw that the technology was reasonable. It wasn't perfect because that was ChatGPT 3.5 at the time. And one of the areas that showed promise was actually project work. And that is one of the largest clusters that we have within the center. In 2024, we repeated the study. And when ChatGPT 4 and 4.0 came out, the ability to pass assessment tasks really accelerated. Even though it still was not perfect, we could see what was coming in the year ahead. And in 2025, we didn't even repeat the study because there was no need to. And the technology has really exceeded our expectations. But from this, we created a security matrix that provides an insight to short-term and long-term security options, as well as opportunities for integration. And from it all, further evidence was provided that project work, especially open-ended project work, could really benefit from generative AI integration. And we say open-ended, especially because of the fact that open-ended has no one correct solution. So students can engage with prompting sessions, but as they don't know what the actual correct answer is, it provides great opportunity to check out their evaluative judgment skills. Anyone who has taught open-ended project work knows that there are many different problems. It's not a simple task. We have assessment challenges. Students struggle with team dynamics and time management. We have uneven student performance, a lot of discomfort because of the lack of scaffolding, and many resource constraints. But many of these constraints can actually be supported and learning enhanced if we were to integrate them using generative AI. It can actually be a supporting tool to support students through that process. The two key types of project type learning, we have project-based learning, which emphasizes on the application of knowledge. And then we have problem-based learning, which focuses on acquiring knowledge. So here, when we talk about project-based learning, we're really talking about those learning experiences where we're looking at the application. And that application requires knowledge from various different sources. That's from the students' experiences, their knowledge is gained from all the scaffolded subjects leading up to your project subject, as well as knowledge from academic and non-academic literature. And now we also have the option that they can also integrate knowledge from generative AI. And regardless of where this knowledge comes from, the students need to be able to synthesize that knowledge to critically analyze and think, what are the best components from each source that lead us to the best solution possible? So what this process does is it takes our mindset from trying to monitor cheating from the student and pushes it towards learning. How can we use this technology to help students learn? And this requires a connection between the AI system and the human, which is usually known as a co-intelligence, and that's the term that I refer to, while others use different terminologies such as a virtual teammate. Now, we have to understand co-intelligence in some detail. I want you to consider three different metrics. One is speed, how much efficiency can be gained from using the technology. Then we have learning and retention. If we were to be asked later down the track, say from a supervisor or our client, how much of the information that we've created would we be able to remember? Then we have risk. What is the risk factor that our work is actually going to be correct? So if we look at just using our cognitive ability, it is the slowest approach. We will learn and retain that information the most, but and it's also the lowest risk in that we are confident that what we write or produce is of a substantial quality. Now, that assumes that you have appropriate experience and skills. So if you are given a project where you don't know that information, you don't know what you don't know. So actually using a technology might be actually able to enhance your understanding and change that risk profile. On the other spectrum is we just plug a prompt into a generative AI tool such as ChatGPT and just trust the output. And that is high risk because we have no idea of the quality factors of that output if we weren't to check it ourselves. So this is where co-intelligence comes in. It's a combination of the two, and there are multiple different layers. One layer is where we do all the provisional work first, and then we apply the AI. But if we don't check the AI output, then we are leaving ourselves open for errors, and we don't want that. The opposite is to use AI first and then apply our cognitive ability to check the work that occurs from the AI. But without doing the mental work first, that again affects our long-term ability to learn and retain that information. So the alternative to that is to use our cognitive ability first, our AI, and then finish off with our cognitive ability. And that is the optimal approach, and the approach that we will be teaching students when we are engaging them with the integration of AI in project work. It's about doing the work first with their mind, enhancing their work through the use of AI, and polishing it off again with their cognitive capability. And we are called this CAC, co-intelligence, cognitive AI, cognitive. And a key part of why we're doing this is this is information from the Future of Jobs report from the World Economic Forum. And this is conducted every 5 years. And the latest report produced this year shows that AI and big data jumped the most in terms of rankings. And the idea of applying AI might be easy, but the employers understand that there's a lack of skills and lack of vision amongst people in order to be able to adapt AI within corporations. So this is where we as educators have the opportunity to help produce that upskilling of staff, of students. This is important. Let's have a look at this study that was conducted on 776 Procter & Gamble experienced professionals. And experience is important because if you are an expert in the area that you're working on, AI is extremely powerful. But if you're not experienced, it is extremely dangerous. So we need to keep that in mind when we're looking at this data. So when we're looking at experienced professionals, this is the quality of a solution. Okay, so this is an individual with no AI, a team with no AI, and an individual with AI. So this data is suggesting that an individual with AI can perform and create better solutions than a team with no AI. So can you imagine the impact on work, on employment, etc., if that was the case? If we have a look at the individual with AI and the team with no AI, there's not really much of a difference. So this shows the impacts of of AI, the potential and the risks that we have going forward. In 2023, when I did my first application, I did see that students could actually produce better solutions if they were using AI to support them. So from this, we created the project work cluster. And what we did is we created a framework using 16 staff from 9 different universities. And it's called the Project Work Artificial Intelligence Framework, or PAIF for short. And it consists of the conceiving stage, designing stage, implementing stage, and operating stage. And it's connected via 4 different substages, which include items that we would usually teach in our subjects. Does this look familiar? Well, it should look familiar because our framework is based off the CDIO framework. And the idea behind this is built upon a systematic literature review that we did, where we realized that academic staff struggle with policy and a lack of training, including knowing where and how to start when it comes to AI integration. So what we did with PAIF is nothing groundbreaking, but it simply documents and provides a process where academics can connect what they do in the classroom to potential opportunities in the classroom. So how do we apply it? First, you would start by having a looking at the PAIF stages and the project work activities that you would perform in your classroom. So you pick and choose only those that are relevant to you. And once you've made a match, for example, if you look at brainstorming, this is the AI integration opportunity. You apply that using co-intelligence and getting the students to consider the ethical considerations as well as prompt techniques, especially evaluative judgment. And evaluative judgment is the key to all of this. Teaching the students that they need to understand the quality process, the quality checks, that their work is fit for purpose. So the question is, all right, here we have some words for the text, but how do you transition from the activity to the actual application? To help you at AAIEEC, we have started creating resources to enable this to happen, and they're available via the link shown on the slide. To further support this, I have started creating video guides, and these are the first 3 videos. The first one is an overview of PAIF and how you would implement it. The second is a guide for students on using generative AI tools. And the third is a focus on co-intelligence. In terms of the different stages, I have been able to create the first video, which is on problem definition and root cause analysis. And over the next 6 weeks, I'm using these resources for my students in an upcoming subject, and I will be creating many more videos, so watch out for them. The idea is that there's no one correct way. I focus on generative AI, but PAIF is about any AI technology, and the different institutions will be implementing it in ways that suits them most. And that's what we're doing in terms of research, working out what are the different ways of applying it and how does that impact us. And finally, we have a AI stream at the upcoming conference, which I encourage everybody to attend. And we'll see you into the future. I've gone over time, so if there's any quick question, I can probably take one.
Hi, Sasha. Sorry, may I have a very quick question?
Yes.
Thank you for your great presentation. I'm Lucy. Currently, I'm a lecturer at James Cook University. So, may I know, like, for example, now generative AI is very common. So, will that affect, students' skills to communicate with their peers if they rely on these digital tools heavily?
It can.
Yeah.
It can impact them if they concentrate all their effort and time on doing that. The idea is that we need to continue all the transferable skills that are part of the Engineers Australia accreditation curriculum. We can't, like, not every subject has to teach AI. Okay, it can be just one subject in the entire course, but we as educators need to at least provide the foundations. The students know what they need to do when they leave university. That's in my opinion. Okay, let's move on to the next presenter since I went over time.
Awesome. Thank you so much, Sasha. It was a great presentation. A lot of value that we can use in our product as well. So good morning, everyone. My name is Dr. Swapneel, and I'm going to be co-presenting with my colleague Giordana Orsini Florez. We are from the Faculty of Engineering in UNSW, and we're working on our project White Hat AI Hacking. And we have a big team, as you can see on the slide. But today we are going to be talking to you about using how we've used AI to inform assessment redesign. So in two phases, the first one was ethical hacking and then conducting a code design. So in our agenda today, so first of all, I'm going to give you a quick brief of the methodology of the ethical hacking framework we used as a diagnostic tool. And then majority of our presentation is going to be within the code design workshop that we introduced and we worked with our academics. And what's next? So where are we going with this project and what are the things we are going to be working on? Let's go straight into it. So in terms of methodology, we've used a live course assessment to do this. So in our live course, we had the students submitting their submissions, and we also generated some AI submissions, which were then mixed together. We then de-identified those submissions, then gave them to our blind markers. So the blind markers were aware of this research study, but they just didn't know which submissions were which. So they did the usual thing. They gave feedback, they provided the marks, but they did also one more thing. So we asked them to indicate if they felt that the submission was an AI generated or a student submission. Once they did all that, they gave it back to us. We again re-identified that and we segregated them in human and AI. Of course, this is an oversimplification of the entire process, but there's more to it. But what we then did was we came to this point where we had the data of different assessment areas using the rubric criteria where humans do better. So we look at the difference. So where humans do better is something that we want to really encourage more of. Where AI is doing better, that's where we actually really want to look at how do we ensure that to assure those learning outcomes and rethink different ways of introducing that learning for the student. And we did a lot of data analysis, which I'm not putting in this slide, which then formed us for our code design workshop, which Giordana is going to talk to you about.
Thanks, Swapneel. So I'll talk to you about our co-design workshop model, and I'll just give you a brief overview, and I'll walk you through the different stages of that. But as a summary, it was a very structured workshop. We followed a certain structure that I will provide details of in a second. It was collaborative in nature because us educational designers met with the academic, and we really worked together to help the academic redesign that particular assessment and improve the overall assessment and the course. It was really targeted to the course and assessment needs. And what we wanted was to make the most of the time that we had with the academic to really help them make those changes. Next slide, please. Thank you. So the first stage of this co-design workshop was a pre-workshop research. In order to make the most out of the time that we have with the academic, we had to do a lot beforehand. So we did the analysis, we summarized the vulnerabilities so that we could present them to the academics. We also did an in-depth analysis and understanding of the course before meeting the course convener to make sure that we really understood the context, the constraints, the learning and teaching activities, opportunities for alignment. And then we looked at any evidence-based approaches that could help inform that assessment redesign so that we could come up with real solutions to the problems that we could see or opportunities for improving that course. So in the workshop in itself, we started by presenting those vulnerabilities, as we call them, or areas where we could improve the assessment. And we chose to do this in the form of graphs and charts because it's just easier for understanding and comprehension. As part of those graphs and charts that we presented, we provided a breakdown of the rubric and how the AI submissions versus the student submissions did for each of those components of the rubric. Something to highlight is that this was not just a presentation of these graphs, and we didn't want to just present these, but we wanted to have a conversation with the academic. It was an opportunity as we were presenting this for the course convener to ask questions about these findings, and also for us to seek clarification from them, because we might have interpreted some of those findings in a certain way. But as we were not the ones teaching the course, we wanted to really make sure that we knew exactly why certain things were occurring, or what assumptions, if our assumptions were correct. So then we moved on to the evidence-based discussion and reflection. At the time when we first did our first co-design workshop, the policies that we had at our university were quite new. So we wanted to make sure that the academic understood what the policies around AI use and AI permissibility within assessments were. So we focused on that. In the second pilot course, we didn't focus on that as much because people were more familiar with the policies, only the areas that were pertinent to that particular assessment. We also looked at frameworks such as the assessment design decisions framework, which is a really good framework to help you think about what are key decisions that you have to, or key areas that you have to consider when you're redesigning your assessments. How does it impact many other areas of what you do? What's your context? What is the implication of making changes? And we also looked at opportunities for constructive alignment. So at times, we just wanted to make sure that the assessments were really aligned with the learning and teaching activities. These assessments that we did look at were really well aligned, so we didn't really have to do much in terms of alignment. And then we presented a series of evidence-based suggestions that were carefully picked to address those vulnerabilities. After doing that, we had a series of questions that we sort of discussed with the academic to help them think about what they could do. Those questions centered around AI use in industry. So we wanted them to reflect about what they knew in terms of how AI was being used in industry and opportunities to do that within the course. How could we incorporate more of that AI literacy for students in terms of academic integrity, but also opportunities for professional development for the students? For these particular courses, the assessments that we looked at were reports, so they were very product-based. So we really had to focus on shifting from product to process. And we also looked at feasibility of changes and impact on the course delivery within the course and context constraints. We wanted to make sure that we weren't proposing anything that would be an additional workload for the academic or for the student that wasn't sustainable. We really wanted to support the academic in making small sustainable improvements to that assessment that really had impact on the student experience and that the students really saw as valuable, as well as the academics. And that's an important aspect of how we targeted that workshop. So after doing that, we came up with what we call an action plan. So doing all this reflection, we said, okay, we've talked about these different elements. These are the certain parts of your assessment that we consider are most vulnerable or that we could really redesign. Which of these things do you think is most suitable, and what can you do within the time constraints that you have? And then we provided follow-up support where needed.
Thank you, Gio. So after going through all that, what we found that our educators actually, there was an increase in our educators' confidence to provide opportunities for students to collaborate effectively with AI, to capture the evidence of the student learning throughout the process, throughout the life cycle of the term, and to design assessments that promote ethical AI use, especially from within the professional contexts, and also to apply the assessment for learning principles, so that we can to design assessments that promote assurance of learning, so that the students feel well supported throughout that learning journey, and to not have to rely much on AI as a cheating tool, rather to use it for learning. So, and another big aspect of some main key learnings were that academics say that the biggest hurdle for doing any sort of change is the time and the resources, the constraints that they have. So a co-design approach actually helped them reduce that time burden and provide, and they got that ongoing support. And as Gio already mentioned, more achievable changes while leveraging the existing opportunities in the course. So every course has their own challenges and opportunities. What we did was just try to tap onto the existing resources, and we made achievable changes. So that worked out for us. And solutions are always context specific. What worked in one course does not mean it directly transfers to the other. So it's that this holistic way of looking at deep diving into the course and finding specific solutions was highly impactful. And what we've also found was that we need more insights around how AI is used within the industry, because when we talk to the academics, they often don't have that background on how it's being used, so that that can be transferred to our student learning. And there is a need for more regular course reviews, especially in the context of AI, because now that we are things are moving so rapidly that if we need to keep adapting to how we teach students and how do we maximize their learning, and that should be a focus. So a regular course review has become even more important than ever. And what we also found from our phase 1 is that markers could have some biases about AI writing. And that's why and a structured guidance on providing them structured guidance on how to actually how do they actually navigate those influences and bias is important. So moving forward, we in this co-design approach, we had the educational developers and the academic. We want the voices of the students, industry, and academic peers moving forward, so that we have their voices into this co-design approach. And we want to, and also another very important thing is that we don't look at AI as a challenge, but rather an opportunity. So it acts as a catalyst for change. It's like a new chapter where we could start looking more at the programmatic level design, better feedback mechanisms, and how do we work more in collaboratively in course design rather than working in silos. So it's a great opportunity for that. And we have presented this work in A Squared E Squared last year, and also in ICERI 2024. We are going to be presenting our current work in A Squared E Squared 2025. So thank you so much for listening, and yeah, open for questions. Yeah.
Thank you,
Sorry.
Giordana and Swapneel. Thank you very much. Can you stop sharing and the next presenter can put their slides up? While that happens, happy to take one question.
Can I ask a quick one? I guess I know it was great presentation. Thank you. I was just wondering, I'm interested with specifically what, if you can talk about what generative AI activity, I guess specifically the course convener used would be amazing. Yeah. Or
You
talk
mean
through
in the redesign?
as in how the implementation. Yeah, just.
Yeah, so in terms of the redesign, there were elements where the academic felt that AI could be used to better their structure of the reports and everything. So they encouraged students to use that for more grammatical things. They were fine with that, to help students engage with that element. And also now, I think in the second redesign we also found that the marking criterias and the rubrics were we found that they were not aligning with what we want to do with AI, with our findings. So now there's an opportunity for us to improve the rubrics and see what's actually relevant and how do we maximize that learning and make an in-depth rubric that will help in student learning rather than relying on other things. So these are just two examples. There's many, this was a 2-hour co-design workshop. So there's many more, but we can talk more about this and we can let you know what we did. Yeah.
Okay, thank you very much. We now move on to our third presenter, which is on AI ethics from Zach Quince, which is a really important topic that everyone is really interested in. Thank you.
Hello, welcome. Thank you. Yes, thanks for the introduction, Sasha. So today I will be talking about AI ethics in higher education. And today I'll be giving a presentation on one of the projects from the ethics cluster, which is on behalf of all of those people there, which I won't name, but a fair few of them are in the call now. So just before we get started, obviously, I would like to pay my respects to the ancestors and descendants upon the land we work, meet, and study today. So with this particular study, what was the context and what was the goals? So the context basically comes down to GenAI tools like ChatGPT are really transforming engineering education. Back in 2023, when the tools first came out, I distinctly remember, and this was a very big turning point in what I think will be my career, is there was a group of students who were trying to solve very basic, very standard Ohm's law problems. And they thought that GenAI and ChatGPT were the answer, that that was going to revolutionize their learning and the engineering workforce. Back then, ChatGPT 3 couldn't even do Ohm's law correctly. So it was a very interesting dynamic of students seeing this, tool and technology and thinking that all of its outputs were correct, and me looking at it going, yes, but it can't multiply. So instantaneously, my mind shifted to, we need to start thinking about some core themes of skills, which is ethical use, human interaction, co-intelligence, all of these different things that really are required in our profession now. So this particular study looked to explore the ethical implications of GenAI as perceived by engineering academics. So where is a really good place to get a big group of engineering academics together? At A squared E squared. So the methodology for this one was pretty straightforward. Of course, being a workshop at A squared E squared, we didn't want it to just be a data collection moment. We really wanted to try to embed some of these core themes and have a really rich discussion whilst capturing some of these ideas. So the group ended up being about 15 academics across Australian and New Zealand universities, all incredibly diverse teaching disciplines and career stages. So we had a really good mix of thought and experience in there. What we did was we had 4 specific case studies, and we have developed those over the past, I guess, 12 to 15 months, and we've used them in lots of settings with students, with industry, with academics. And the 4 studies basically looked at academics' use in learning and teaching, academics' use in research, industry use of GenAI in the workplace, and student use of GenAI in their learning. Now, what we wanted to do was we wanted to see what ethical considerations were considered with each of those different scenarios, because obviously, as you can probably guess, there is going to be different considerations if we're talking about students for learning versus industry use. Now, the big question at the time was, well, how do we actually do this mapping? And lucky for us, we had a publication that was on the way, which has now finally gotten out of peer review and has now been published, which houses a framework that has 32 of the GenAI implications or considerations of use. So with that in mind, what did academics kind of link to these case studies? So when we're talking about case study number 1, which was academics for teaching practice, we saw a lot of issues. And again, I use the word issues because, again, there actually wasn't many positives that really got brought up, except for kind of the first one, which was efficiency in processes. So academics identified that we were able to see some gains in efficiency. Of course, we had some concerns in loss of collaboration, data ownership, integrity, transparency, and where that human intervention actually lies. Moving on to the students' use, we had pretty much what you would expect to see. So we had what happens if the students depend on AI. They're going to lose skills in terms of ideation and reflection if they don't use it properly. There's going to be adaptation issues, and the big one, which is more of a systemic issue across the board at the moment, which is the risk of reduced learning opportunities. Contrasting industry, we had some, I guess, more positives, but still, again, we're looking at through a very critical lens. We saw automated processes being accepted, which was a big one. We saw the environmental impact. We saw issues surrounding IP and data origin, integrity and accountability challenges. And this was a big one within that discussion, because as part of this workshop, we also asked, are the EA Code of Ethics all-encompassing to incorporate GenAI? And of course, we had a very split room. I think we had 7 and 8. Yes, no. And we had some very, very rich data pulled out of that as well. But again, we're looking at that ethical data practice, the environmental sustainability, and the accountability risks, again, as you would expect in industry. Moving over to academics for research practice, this was very kind of different to what we saw in the first case study. Now, whilst the themes mapped reasonably well together, we saw a very different way of thinking. So in the research side of things, we saw, again, the environmental impact like we did with industry, but that wasn't in the academics for teaching practice. Again, we saw the dependency on AI, integrity issues, and data origin concerns. So again, nothing, in my opinion, groundbreaking, but it was really good to see the difference and which codes and which themes emerged from each of those case studies. So once we did our thematic mapping, we looked at our 32 item framework and we said, okay, where did everybody kind of group things together? What we did is it came down to about these 10, and it came under automate processes, bias and intellectual property, collaboration and ideation, data ownership, security and collection, decision-making risk and uncertainty, environmental impact, didn't fit with anything else. So we decided to give it one all on its own, and I think it's probably warranted. Equity and accessibility, human labor, integrity, transparency and accountability, and quality output and understanding subjects. So this was kind of the 10 themes that were kind of grouped together and emerged out of that mapping process. So you are probably sitting there going, so what? What's the implication? What's the findings? So the implications are for teaching practices, themes like collaboration and ideation and quality output really need to shape the classroom guidance on GenAI's responsibility and reflectivity. Curriculum design, we need to incorporate bias, data ownership, environmental impact into modules or learning outcomes to actually raise student awareness. Staff development, we need to think about the automated processes. We need to continue that conversation on transparency and accountability when using tools. As you are probably all very aware of some cases that are rocketing around the internet at the moment regarding academics using the tools to teach the students, but the students not able to use those tools in their learning. And the big one was institutional policy. So data security, human oversight, and equity really need to be part and be a tailored and proactive approach into institutional policies. What does this look like for the future? So in the future, we are planning to run this again in 2025, and we are then going to be publishing the 1-year longitudinal differences between 2024 and 2025 to see what has changed. And I feel like I'm pretty on time. So that's it. Do we have any questions?
Thank you, Zach.
I have a question, if that's okay. I like the presentation. I think it's good that we are thinking about the ethical implications, but I kind of wonder if the so what needs to go further, like things like environmental impact or intellectual property and copyright infringement are pretty big. Like Disney is suing OpenAI for copyright infringement, and presumably that outcome can mean the end of publicly trained generative AI as we know it. Is it enough to just say we'll raise awareness but still use the tools as normal, or is some of these impacts, would that change how we would use these tools at all?
Before you answer that, Zach, can you just stop sharing so the next presenter can get their slides up.
Yes. No, it is a big one. And a lot of it's weird. So in higher education, we went through this period where a lot of people went, no, we're not going to use the tools because we don't know how to use them and we think that it's going to impact student learning. Then we went, well, everyone's using them, we've got to figure out how to do it. But now what we're moving towards is let's train students, let's train staff, let's go through and do all this. But I do think that environmental aspect specifically is really missing from these conversations. I mean, Google didn't hit its carbon emissions scheme last year because of Gemini. We had, we've got countries talking about nuclear energy because of AI farms, not because of the energy crisis in the world. So these are giant conversations, and I don't see a lot happening about that. But in a lot of my training, I do try to preach kind of more sustainable training in terms of if something is easily found or something is easy, let's do it that way instead of going, oh, well, can you please highlight where this is in this document? Well, why don't you use the Adobe PDF search that doesn't computationally cost anything? I think eventually those practices will start getting into the system and we will see this kind of leveling out. Until then, the only thing, in my opinion, and as a very, very small fish in a very large ocean, the only thing that I can do is try to get that message out there. And I know that's not the answer that many people want or need, but that's honestly the best answer I can give.
Yeah, thanks, Zach.
Thank you, Zach. Now we move on to our last speaker in the showcase, and that is Aneesha from University of Queensland. Thank you.
Okay, so thanks so much for having me today. I'm going to start by saying I attended A squared E squared for the first time last year, and I found it to be a completely transformative experience, and have now had engagements with a whole new community that I wasn't exposed to before. So I'm here really to talk today about some online modules that we've been creating at the University of Queensland, with the aim of embedding AI-assisted coding within our curriculum. I'm presenting today on behalf of a larger team, and also would like to acknowledge the research assistants that have been working with me, in particular, Mr. Lachlan Miller. So no one here would underestimate the capabilities of large language models. They've had a tremendous impact, not only on generating, things like essays and images, which were the first, sort of benchmarks to fall, but also their code generation capabilities. And I'm actually citing a lot of publications that right now seem quite old, but even early 2023, slightly after ChatGPT got released, and slightly before with some of the advances that were taking place, a lot of our programming subject matter was going to be impacted, and these models have just gone better and better and better. And it's not only introductory programming. Subjects like web development and even data science have been tremendously impacted in terms of the code that can be generated. So a previous bit of work that I actually undertook was to look at how technical publications, so these are commercial technical publications, how these are actually changing in response to this generative AI being introduced and its ability to actually program. And one of the things here is that quite early on, some books were changing their approach to how they were teaching programming. And particularly at that time, it was a smaller number. I'm sure that has tremendously increased at the moment. And it just shows that these technical book publishers and the authors writing these were doing this slightly before academia had actually responded. And it's almost as if they were teaching students a new set of more advanced skills. So things like, thoroughly testing your code, how to properly debug, having reading code as a core skill, and then different architectural approaches you can take to design software systems. And so ultimately, this to me was the way we need to teach programming, and also what we can build is fundamentally changing. As part of a larger team at UQ, we applied for and got a teaching innovation grant. We call this the Creators of Tomorrow grant, and it was really looking at prompt engineering and trying to embed AI assisted programming as well as responsible AI within the curriculum. Acknowledge everybody that's part of this larger team that's quite cross-discipline across different faculties at UQ. And in particular, Professor Kate O'Brien was instrumental in assisting with the grant and some of the early ideas in going ahead. We also are co-designing with academics, tutors, as well as students. So what are some of our design guidelines behind this module, basically? Okay. Some of these have to do with what we want to teach, but also very important was easy way to author these modules and a way that we could easily update them. Part of this also was just, and this links to teaching programming fundamentals in this module, we wanted a live code editor embedded where students could try out Python and R code while still not requiring a lot of server infrastructure, because we know beyond having grant money, this becomes hard to maintain and fund. We really wanted to have a strong emphasis on programming fundamentals. We also wanted to teach prompting techniques. And in particular, what we wanted to teach students is how to learn with AI. AI is going to be there alongside humanity, I believe now. We cannot just concentrate on the fundamentals without AI, because my fundamental belief here is what we want to be training our graduates to be is lifelong learners, even with AI. And then, of course, the responsible AI aspect, which is responsibility, from the perspective of a student, but also the responsibility from the perspective of someone that's actually building software that goes out into the world. So our first module was for AI-assisted data analysis. You can see here the structure, very strong emphasis on understanding the limitations of the models as well as the capabilities, strong fundamentals and building up some skill in that area, as well as then teaching students how to write prompts and learn with AI. So you'll see sections on learning with large language models, and then building up skills in terms of being able to read code, writing reusable code, and then debugging skills inside here. One of the key things, and particularly on the updating of the module and being able to embed code snippets, was using Quarto, which is a great tool for going from Markdown to almost any other format, including a website. At the moment, or in semester one, I should say, this particular module was trialed into chemical engineering courses that use data analysis. I did say a key guideline we were using is that we actually wanted students to be able to run code, even data analysis code. And we found this great extension for Quarto called Quarto Live. Now, this has actually been amazing for the module because it actually is using PyIode, which is an extension that allows Python code and a number of Python libraries to actually run in the browser. So you don't need any sort of server-side technology, and you can make these exercises where students can basically type in, run the code. In our case, it's interacting. We direct them to interact with a large language model and then come and try out the code inside here. I spoke about the particular focus on, reading code, the ability to read code becoming much more important, because you're now generating a lot more code, and then you need to be able to read it much more. This is perhaps a skill that develops, even after students actually complete an entire degree program, and you're needing to bring these skills up a little bit earlier. And so a good way to do this is explain in plain language exercises. And so we've developed an extension for Quarto, where you can see a code snippet, run it, do some trace through it. And then there's explain in plain English. And here the feedback actually comes from a large language model that can in some way grade those and provide feedback. We also have an AI-assisted Python programming module. So this one has come later, and you can see how we've developed our focus a little bit more, and we'll now actually put some of these new findings and techniques with content that we're covering back into the data analysis module. Again, very strong focus on just getting students back into some of the fundamentals. You can see here more of an emphasis on evaluating the output. And so this is that, and Sasha mentioned this in his talk, this whole evaluative judgment is becoming much more important. And so we've added sections like this, but you can see we're also, how to actually test your code, how to do functional decomposition. These are all skills that you need to develop alongside generative AI. Initial findings, basically, what we found is students can't do this module all at once and learn. It's something they'll progressively need to encounter with sections through their course. And so we're trying to make the sections a little bit more standalone. You can almost see some of that reflected in the Python module. We're trying to balance, just this prompting strategy of one shot, where you really think about what you want and put everything in one prompt, versus more conversational prompting style. And also we actually think that Quarto Live has worked really well and actually helped a lot of students get back into Python programming and data analysis without, and enjoy that work without having to go through installing a whole lot of things. I should say and acknowledge that the first draft of all our modules actually use an agentic workflow. So we actually create the sections, we prompt all the ideas and what the code snippets should actually be, and then we ask the model to actually generate it in Quarto or Markdown. And we have this agentic workflow that can process all of those, pull those files together, and actually give it to us in the Quarto structure. And that serves as the first draft, obviously still heavily edited, modified, but we found it was a great way to get that initial draft starting point. That's the end of my talk. I've put some links for further information on me. Thank you.
Thank you, Aneesha. If you'd like to disclose your sharing, any questions for Aneesha? What is your biggest challenge, Aneesha?
I would say the biggest challenge is I think students have really embraced AI and use it all the time. I think academics really try to concentrate a lot on fundamentals without approaching how someone learns with AI. I particularly myself think what we're actually the most important thing we can do for our students, given that this AI is integrating, and embedding in all the tools that we work with currently, it's hard to completely focus on, just fundamentals without it. And through your career, it's pretty much going to be lifelong learning. And so the skill to have something that's intelligent and be able to work with it while you still maintain your cognitive ability, I think becomes the most important skill that we can teach our graduates.
Some wise words there. Okay, thank you very much, Aneesha.